Excellent, thank you. So welcome everybody. My name is Dave Blodgett. I'm your host for the ESIP Information Technology and Interoperability Rants and Raves seminar series. This month we have Julie Padilla with us from USGS's Water Mission Area Data Science team. And Julie has a presentation that she gave at our recent USGS Community for Data Integration kind of face-to-face meeting. I guess it was about a month ago now. And it's on a topic that was of interest to the group previously. And I'm really excited to hear from her. So it's about reproducible data pipelines in modern data science. Largely focused on targets, but there's definitely going to be some kind of background concept stuff that's probably going to be useful outside the context of R. So hopefully everybody finds this interesting and useful. And next month, I do have somebody lined up. The team from the EarthCube Model Data Research Coordination Network project, largely Unidata folks, but some academic model data specialists will be presenting an update on their work. So I'll be updating the group on that as soon as I get a title and abstract from them. But that is scheduled, and then August is also scheduled. We're going to have a presenter from Posit, the formerly RStudio team, come in and talk about Quarto, the technology that's kind of an evolution of our Markdown. And yeah, so I'm looking forward to both of those talks, really looking forward to what Julie has for us. And with that, I would turn it over to you, Julie. So thank you so much for taking the time.
Great, thank you, Dave. I'm gonna share my screen here. Okay, Dave, can you give me a thumbs up if you can see my screen? Yep. Great, okay. So hi, thanks for the invite. Welcome to this month's meeting, and spoiler, this is mostly a rave. So what we're gonna get up to today is I'd like to cover 4 topics. We're gonna take an introduction to reproducible research pipelines, what they are, and I'm gonna have a brief overview of the skills needed to get started with pipelines. And based on a little background research, I've made a lot of assumptions about the skill level of folks on this meeting. So, and that assumption might not be right. So if you're sort of following along with today's meeting and you're like, wow, I think I'm missing some of these core concepts, shoot me an email and let's talk about them, because in my CDI presentation, it was a longer version that included a breakdown of all of the individual skills. Then we're going to hop over to an overview of fully reproducible pipelines, and then we're going to take a look at a pipeline template that we built last year. So that's a lot of content to get through. So I thought I would put a takeaway slide right at the front, just so folks don't feel overwhelmed. There's really 3 big takeaways here. Reproducible pipelines aren't just for highly collaborative software teams. They really benefit individual researchers as well. Pipelines can help you reliably scale your analyses as you add more data. And thoughtfully written pipelines can be used again and again to speed development across multiple projects. So now we're gonna talk about some of the core concepts of reproducible pipelines. We're not gonna fully cover the ins and outs here, but we wanna really provide the motivation, background, and an overview of the tools we use to do this stuff. And we wanna make sure that we're on the same page about vocabulary, about what we mean about terms like reproducible and pipeline. So before we talk about what pipelines are, I wanna begin with the motivation. You know, we have 3 scenarios on the screen that I'm deeply familiar with. A collaborator found some bad data on one of their site records, and can you update the analysis? Hey, great news, a cooperator found my data analysis really useful and they want an updated version every 2 years. How much time will it take to do that? Or a third case of could you reproduce statistics from your most recent publication or report? And could you do that for a publication or report from 5 years ago? So I want folks to sort of take a minute and think about how you would approach any of those scenarios. You know, what would it take? And on a practical level, in terms of data code or GIS steps, how long would that take you? And the answers vary. But when we consider these scenarios that come up in our work, we need a couple of things. We need to ensure reproducibility. We need to be able to trace our data preparation, the processing and analysis steps. And we need reliable code that is reproducible, robust, and efficient to run. So we can run it again and again without taking too much of a time hit. And we'll mostly be talking in terms of software and software code, but these general needs apply to other types of workflows as well. So when we say workflow, we're talking about a sequence of steps that are used to accomplish a task from start to finish. And this can be anything from a scientific work product to like, a recipe as a workflow. And that's a popular analogy that we like to use, where we start with a list of ingredients, and then we have instructions for how those ingredients are combined together, and then we have an idea of what the product looks like at the end. At USGS, a workflow may look something like how data flows through a project from raw data to processing to plotting. And here we've sketched out a workflow that for a project that basically does that. It takes a variety of sites from the National Water Information System, it downloads the data, it processes the data into some sort of clean format, and then it plots the data. Capturing these steps in code and documenting these processes is already a big step forward for reproducibility. But there's room for improvement. When I use the word pipeline, I'm talking about, in contrast to a workflow, a pipeline is a programmatic implementation of the workflow that involves minimal human interaction. So the goal is to write code that could be executed non-interactively and by a machine. And it's helpful to think of a pipeline as a project and workflow management software, and I'll show you why. So here's the same workflow from before. And to extend our recipe analogy, the data are the ingredients, and the code specifies how it all gets combined together. So if we carry out this project, say data from one of our sites has to be updated after going through, it's not an uncommon process here for results for a gauge location to be updated over time as they go through QA/QC. And we can think about that data now as being a spoiled ingredient in our recipe. And the result of that is that everything downstream in our pipeline is also now spoiled. And so what we can do, but not everything in our pipeline is spoiled. So what we can do is when we rerun the pipeline, we're only rebuilding all of the steps that need to be rebuilt. And this is a relatively simple data pipeline, just to sort of show the ins and outs of how pipelines sort of manage the workflow and changes to the workflow. And in contrast to that, there's two alternate approaches to using a dependency tracker. Like if you don't use a dependency tracker to keep track of all of the steps in your workflow, you really have two situations in front of you. You can either have complete faith in your ability to determine and remember the freshness of each ingredient in your pipeline, in your workflow, or you can have zero faith in making that determination. And anytime anybody asks you to reproduce something from your workflow, you rerun the whole thing. For this simple example, that might not seem too time intensive because this is a pretty straightforward project. But the reality of the science world that we live in looks a little more like this. It's a lot more complicated, and it's a lot harder to track the changes in your input data sets over time. And then on top of that, a lot of the work that we do is with teams. And you may have teams with mixed abilities. You may have some folks who have expertise in data science, and you may have other folks who have domain expertise, so they might not be as strong at coding as you are. And so what the pipeline allows us to do is we can track changes over time while working collaboratively. And ultimately, it allows us to grow the size and complexity of our data analyses. It allows us to integrate varied data skills in collaboration. So where somebody may not have the strongest coding skills, but they have 30 years of research experience in the domain that you're working in. And it allows us to verify that we've met requirements for data models and metadata. And this is something that's important to folks who work at USGS. So these are some of the challenges that we use pipelines to resolve. And those are some of the motivations that we have for doing these tasks. And so ultimately, using a pipeline over a workflow makes it easier to iterate and collaborate with others while improving code into the future. So now I'm going to move into our second topic. This is really a brief overview of the skills needed to get started with reproducible research pipelines. And as I mentioned earlier, I've assumed a lot about the technical skills of the folks in the room. And for that reason, I'm really only going to briefly cover these. And one of the reasons I want to do this is because I think it's worth reminding ourselves where many of us started on our coding journeys and where many of our colleagues and collaborators might be in their own processes. So now we enter the We Rant section of this presentation. I can't emphasize enough. I work on mixed programming skills teams all the time, and I can't emphasize enough how unintuitive it is for folks that have been scripting for a long time, taking scripting approaches to doing their work, have been doing it for a long time. And they probably don't think too much about software development, nor do they think about data science as a discipline. They're really focused on advancing their research and using code to do that. So, to take folks like that from a scripting approach for data analysis to a fully reproducible pipeline, that feels like going on a day hike on Monday and then on Friday trying to decide that you're ready to, free solo El Capitan. And so when I talk to folks about this, I really break it down into steps, and we think of this as tiers of reproducibility. So, when working with mixed use teams, if you're writing scripts, that's already one step down the pathway in the tiers of reproducibility. The next step in that progression is really understanding and organizing your scripts and your data inputs, and then the outputs you produce from that. Then the next step is taking all of that information and writing functions that are used to capture your analysis steps. And then those three pieces combined can be used to help you enter the world of fully reproducible pipelines. And I also want to add here that each one of these steps is important. Each one of these steps improves code reuse and value. And so when I work on mixed use teams, we really just try to walk people up through these tiers until they reach a point where they're ready to produce pipelines or contribute significantly to pipelines. And the assumption that I'm making in this group is that folks here know how to write scripts. They understand the importance of organizing scripts, inputs and outputs, and using functions to capture data analysis, steps of your data analysis. So we're really going to kind of jump right into the fully reproducible pipeline component here. And I want to say, if any of these intermediary steps are unfamiliar with you, email me, because part of the longer presentation involves a set of curated resources that will sort of get you pointed in the right direction on some of these intermediary steps. And so now we're going to hop into an overview of the pipelines themselves, how they work. I'm going to take an R-specific approach here, and I'm going to talk about the Targets workflow management software package. But that selection is based on my area of expertise, and all of these concepts, from what I've seen so far, translate to other programming languages. So, for example, if you're a Python user, there is a workflow management software package called SnakeMake. And I assume that they also exist for other programming languages, for the ones that interest you. So if you've been programming for a while, you may have heard of workflow tools such as Make or Remake. And Targets is similar to those tools, except for it's our specific implementation of workflow management software. So if you're used to working in R and R Studio, Targets works just like a normal package. And the key things you need to have in place before you start working with Targets pipeline is you need to have your analysis broken down into functions. Those functions then get assigned to targets. And then all of that goes into a file called targets.r, and you use that to run the pipeline. Some of the other things that we really like about the Targets package is that it is well documented and actively maintained. So, we've put in a number of questions over the past couple of years into the targets package, and we always get really snappy responses, and it's really, really nice. There is an extensive manual for working through a lot of the details of a lot of the examples that we're going to look at today. And then finally, I'm going to introduce folks to the practice problem. So we're going to do a very simple data analysis to show folks the ins and outs of targets functionality. And we're going to do that by taking a look at data from 4 USGS gauges that were recently featured in a Twitter contest from the Water Resources Program called Gauge Greatness. And before we take a look at the hands-on approach, what I want to do is I just want to sort of show you the difference between having a script that has the data analysis broken down into functions and how that would look as a targets pipeline. So on the left, I have a script-based approach. If I wanted to produce the outputs here, I would have to select the whole file and run it. But you can see components of the tiers of reproducibility in here. You can see that I have my functions stored away in a different location than my script. You can see that I've written a few custom functions to access my data, combine it together, and then process it, and ultimately create and save a plot. And then we have the exact same thing on the right. Now we're calling the targets package, and we're doing the same 5 steps on both sides, but now we are taking our functions and we're wrapping them in calls to tar target. We're going to talk a little more in detail about some of the core commands you need to know in targets. But like, as you can see, if you're already writing a script and you're keeping things organized in your project-oriented workflow, and then you're writing functions, you are in a really strong position to hop into targets right away. So the final thing we're going to talk about before we hop into the analysis themselves is we're going to talk about a little bit of vocabulary, and this is target specific. So a target is, you're going to hear this word a lot, and it's really a unit of work that needs to be performed as part of a larger data analysis pipeline or workflow. And this unit of work is defined by a function. And that function can either be from a package or it can be written by the user. We're going to look at 2 examples of that today. And what we're trying to do is capture a unit of work. And since we're trying to capture a unit of work in my day-to-day workflows, I tend to write custom functions that then, make lots of internal calls to other packages. Next up, we have the targets.r file. The targets that you want to run are defined in this file. It is necessary to run a targets pipeline. It specifies the inputs, outputs, and the commands that are needed to perform each task. And then when a target is run, the package will look to that file, run the targets defined in that file, and then automatically determine which pieces of the analysis need to be updated based on their relationships between each other. And then finally, there are a lot of commands in the targets package, but these are really the 4 core ones. There's tar make to run the pipeline. There's tar target to declare a target. There's tar load to look at an output. And then there's tar viz network, and that lets you view the connections and the dependencies between all of the targets. Overall, I have found it to be a really powerful tool for managing complex data analyses in R and allowing users to define, organize, and execute tasks with ease and efficiency. It's really a go-to tool for us. And I think I see some questions. Let me just quickly, okay, cool. So now we're gonna hop into some real world examples. Okay, so this is our studio. I have a small pipeline here. You're gonna see a lot of things that you're familiar with. Here I have my targets file. I'm loading my library, and you can see my same 5 steps. I'm defining the sites of interest, fetching the data, combining it, cleaning it, and plotting it. So the very first thing I'm going to do, I've already loaded the targets library. So now I'm just going to run the pipeline. You see a little spinner up. Okay, I just destroyed my results, so I'm going to pretend I'm starting from scratch. And now what you see here, a couple of things are going on. First, all of my targets that are defined in my targets file, I get a little status update on what they're doing. So I can see that a target is started and I can see when it's built. And it walks me down the whole process until it reaches the end of the pipeline. And then it sort of gives me a report out on how long it took. This pipeline is clearly designed to run very quickly. And here's what happens when you run the exact same thing again. Targets takes a look at the inputs and outputs that you have going into your pipeline, and then it determines what can be skipped and what can't. Because we ran tar make twice in a row, we're able to skip a whole bunch of steps. The other cool thing that happens here is that if you run tar viz network, you get to take a look at all of the relationships that are happening in your pipeline. Again, this is a relatively straightforward workflow, but you have a key on the side. So I can see that I've written a couple custom functions here, plot and save. I can see what targets use those functions. And then I can also see what objects I'm feeding in, right? And then not only that, but I can sort of move these around to make pieces easier to see. And the main message here is that my pipeline is up to date. All of my targets and functions are green. So now what we're going to do, and then we have a few other features that we can look at as well. So, you may say, okay, great, you went and got this data, but like, I really have no idea what it looks like. This is where tar load comes in. You can take a look at any individual object. This target specifically is called a file target. So a file target returns a path. However, some of our targets are objects. Now, object targets we can take a look at just like we would a CSV that we read into targets, and we can sort of take a look at what's going in and out. So like a lot of the tools that you may use in a script-based workflow are still available to you in targets. It's just the access methods are a little bit different. So now the question is, what if we start to change stuff?
Hey, Julie.
Yes.
Adil Abdallah asked in the chat, how do you define the relationships between these steps? Can you show how the name of one target feeds into other targets?
Yeah, that's a great question. So what happens is, so this viz network is created off of a metadata file that gets created when you run targets. And the key thing that happens is every target has to have a name and a command. So in order to make sure that this NWIS target gets connected to site data combined, I have to have a way to connect that together. So here's my first gauge. And then what you can see is that I have written a function that takes an arbitrary number of gauges and combines them together. So the reason the viz network can understand that these two gauges go into this object is because I have created a relationship between two upstream targets and my downstream target right here. And the other cool thing, like, as you do more complicated analyses, the other cool thing about this is that like you can use the viz network to decide if you have correctly connected things. Like if I were to forget, let's do this. If I were to forget to add one of my gauges in here and then do the viz network, I'm going to see this little orphan target that goes nowhere. And then I might go, geez, I forgot to connect everything together. And then I can add it back in. And now all of a sudden, everything is up to date. You may have noticed that when I did that little change that some targets switched to blue, we're going to run through a couple of exercises and we're going to get to the details of how that happens, why that happens, and when that happens. So now we're going to get into it and we're just going to start changing things. The first thing we're going to do is we're going to change our raw data because this is an experience that is near and dear to my heart. You have a collaborator that provides you data and then something happens and they need to change it. So the very first thing I'm going to do is access one of my data files. I have everything that's well organized. And I'm just going to go into this guy and I'm going to arbitrarily change something. I'm going to change this from 11,000 to 100. Save that. And now I have changed something in my upstream target list of targets. So I want to see how that impacts everything. I'm going to run tar viz network to take a look at the impact. Look at this. Not only has targets noticed that something has changed in this file, but it also tells me the downstream consequences of making that change. So when I do that, I can run tar make again. And it's going to build some things and skip others. Notably, it's skipping the loading of my other gauge data. And if I look at tar viz network, we're back up to date. So you may be thinking to yourself, well, cool, but it looks like every time you make a change, you have to rerun the whole pipeline anyway. So what's the big deal? Targets not only tracks upstream data sources, but it also tracks changes to your functions. So, sometimes when you're doing an analysis, especially when you get to the downstream end and you're thinking about plots, you might want to just change a label. Like a collaborator comes back and says, hey, I need you to spell this word out. So what we're going to do is we're going to hop into our plot and save function. And instead of, and I have a collaborator who doesn't like this abbreviation for daily mean flow. They want me to use CMS. Cool. I'm going to run tar viz network again. All of a sudden, my viz network looks very different. None of my data analysis has changed, but the way in which I'm plotting my output has changed. So I can see that I've made a change to one of my functions and there is a impact at the downstream end of this. I run tar make again. And the only piece that gets rebuilt is the time series plot. And then the final thing I want to just sort of demo in this section is what about when I want to add more data? So what you can do is you can add new targets. What have I got here? Files. This is live coding, so we're going to sort of hope for the best here. Okay, so I've made a couple of cryptic updates, and now we're going to talk about them. Okay, so the main thing that I've done here is I added a new target to my workflow, right? So now I can see all of the pieces that have been invalidated and need to be updated, and then I can just run my pipeline and get it all to update. So now you might be thinking, Julie, I need a lot more data than that. I'm not going to manually add 1,000 targets, and I write a lot of reports and they all kind of look the same. So the last thing we're going to tackle in this section is we're going to talk a little bit about some of the advanced features of targets. I just kind of wanted to give you guys a sense of the ins and outs of working with a targets pipeline and some of the tools you use. But the answer is there's just like, the possibilities are endless. So I have one more set of examples I'd like to walk you guys through that show you some of these more advanced properties. So we have the same 5-step analysis here that we've been doing. I've just made a couple of slight tweaks. So the scope of my analysis has changed. Instead of just thinking about for specific gauges. Instead, I want to do some kind of analysis for the state of Michigan, which is where I'm from. So I'm saying I have a target that says, hey, I'm interested in Michigan. I have another target that returns to me some gauges from the state of Michigan. And then I do a lot of the same things here. I'm still reading in the data, I'm cleaning it up, and then I'm plotting it. Looks like I ran a little test case. So now what we're going to do is we're going to run tar make, and this will take about 30 seconds to run because this is actually hitting the NWIS web service right now, whereas before I just had some locally stashed data to make the process faster. So what we can see is my states of interest target has been built. Now it's executing a concept called branching that we're going to look into in more detail in just a minute. And then it's working its way through the rest of the pipeline. And what you can see that I have in my output is just a plot of 2 gauges from the state of Michigan.
Julie, we've been chatting about dynamic branching in the chat.
It's coming up. It's coming up right
Sweet.
now.
Sweet.
So, I have my draft analysis and, I'm involved on a lot of projects that do this. We're taking a regional look and we want to scale it up to a national level. So I'm using the Great Lakes Basin as my example. And so now I don't want to think just about Michigan. I want to think about Michigan's neighbors, Ohio and Indiana. So now what we're doing is there's a concept in targets called branching. Branching is taking the concept of split, apply, and combine and using that to manage your analysis. So if you look at what was built when I was just looking at Michigan, I have one branch. In targets, there are 2 methods for branching. One is static and one is dynamic. Static branching is used when you are thinking about, you kind of know how many branches you want. And dynamic branching is used when you are not quite sure. There's always trade-offs with these choices. You may ask yourself what DB94CF22 means, and it means nothing. It's just an arbitrary value assigned by targets. And that's one of the weaknesses of dynamic branching. But you'll see, I think the benefits here definitely outweigh the costs. So what we have here now, I've added 2 new states to my analysis. And now we can see we're rebuilding states of interest. We're skipping our first branch. This is for the state of Michigan because I've already built it. And now it's starting to build a second branch. So this will take, I think this takes about a minute to run. And I've built examples here that are meant to run fast and not be too awkward in a meeting. But I've also done quite a lot of geospatial processing, and sometimes building those targets takes hours. So there are real world consequences for when you definitely would not want to rebuild targets because they take so long to build. We look at our Viz network. It looks very similar to what we looked at in the last set of examples. But we have a new shape here called a pattern. But the key thing here is you can tell everything's up to date. And you can see how our figure changes when we aggregate everything together. And again, this is a very simple example. But if you write a custom function, you can produce all sorts of things. The USGS BizLab, almost all of their recent data visualizations are done completely in targets with sometimes light Illustrator work at the end. So we use this pretty heavily in our day-to-day. And then the final example I want to walk through is what do you do if, what do you do if you have a lot of reporting to do? As somebody who used to do quite a lot of modeling, I think about this a lot because sometimes you just want a little report to come along with a model so you can say something smart about it. I have one more example for you. And this is the same analysis that we've been doing all along, except for we have added a 6th step. And it allows you to create reports from a template. Targets has the ability to create R Markdown templates, to map across, to branch across R Markdown templates and Quarto templates. The example I'm going to show you today is an R Markdown template, and that is simply because it was faster for me to create. But all of the things that apply to Markdown apply to Quarto as well. And I have a very simple template here, where all I'm really doing is I'm loading a few libraries that I need. I'm pulling some targets in, and we'll look at that in a minute. And then I'm just sort of plotting it. I'm saying, hey, this is a report for our given site. And the Viz network has changed a little bit too. I preloaded this analysis. So really the only thing we need to do is our last 3 steps. And what I usually do when I do these reports is I do all of my plotting, and then I create a little table so that I can ensure that everything I'm mapping across matches. And then I create parameters, and then I create a report. And I recognize this is a lot to cover in a short period of time. A lot of this is covered in the targets manual, and that's part of what makes it such a wonderful package to use. So what we're going to do, oh, and then I put my reports in a report subfolder. So we're just going to run tar make to finish the pipeline. You can see it branching, and all of a sudden my reports are popping up. All right, let me, and you can take a look at those. Here's one, and it's, it does all the same stuff that you would normally see in a Markdown or a Quarto template. So we've looked at a pretty simple example here, and I just wanted to really break down the core functionality of a targets pipeline. But again, we're using a simple example, but the reality of our lived experience is much more complicated. So I want to cover one more topic today. I want to cover one more topic today, and it's an overview of ways that you can use these pipelines as templates to speed development on your teams. We're not going to do a hands-on example of this, but this code is publicly available for you to take a look at on your own. And we've really only scratched the surface here. So we're just going to do a broad overview of a template we've created and ways you could create templates for your own teams. So why even make a template? As we said, I work on teams with mixed expertise. Some of us program, some of us are domain scientists, and all of that. And we've looked at a simple pipeline, but as you make these things more complicated, they are harder to build and scale. We really want a pipeline that can scale well. So how quickly can we move from a basin analysis to a regional or a national analysis? And we also want them to be robust to failure. I think the biggest danger I see in pipelines are silent failures, where the pipeline runs to completion, it does something wrong, and you have no idea. So defensive programming is really important. And then the other piece for building templates is that it's easy to find, it's easy to copy, it's easy to track changes over time, and you can keep all the documentation together. And our purpose in building these is we want to build as many of these as possible for commonly used data access patterns that we use for ourselves and that we know other projects across USGS use. So last year we built a targets pipeline template for pulling data from the water quality portal, and it really does 3 things. It inventories data for a temporal and spatial period of interest. It downloads the data, and then we have a little dummy folder called Harmonize, because we find that the data harmonization process is really project specific, but we want folks to know that this is where they would do that in the pipeline. This template is available on GitHub for anyone to use. So if you use data from the water quality portal, you can go ahead and grab this and use it for your own purposes. And we know this works because we've used it across 3 different really large projects already. and we have plans to use it for more. Another benefit from my perspective is that we get to use this pipeline to show people all of those tiers of reproducibility. Like one of the things I'm really dedicated to at USGS is improving programming practices across the organization. So by having a really useful pipeline, it lets me demonstrate to people the importance of A, writing code, B, organizing it well, as you can see here, organized scripts, inputs and outputs. It also shows people, hey, it is valuable to write your code as functions and to write documentation for it. And then finally, again, people will use things if it's easy to get, and this is very easy to get. So, and then not only that, but like, we've sort of reinforced these concepts. We provided a tool that folks can use pretty easily, and we've really minimized the amount of pipelining expertise somebody needs to have to use this thing. They need to understand the basics of targets, but at the end of the day, all they really need to do is to be able to modify the dates of interest and their spatial extent. And then they need to say something about the parameters of interest. And if you have questions about this, we have a lot of documentation for it. There's an informative README that comes along with the repository, but we've also written a blog post about it that sort of provides an example usage of this. And so we've built this for our specific needs, but I'm hoping that folks are sitting on this call and thinking to themselves, wow, we always hit database X. Why don't I just build a template that is the starting point for every project? And then finally, I've taken a very R-centric approach to this today, but I really want to communicate that these workflow management software packages exist in other languages as well. And a lot of the core concepts are the same. Branching, tracking of dependencies, connecting everything together. And the differences are there are just some software specific quirks in there that, make them all a little bit different. That being said, questions?
Awesome. Thank you so much, Julie. It was really, really good. And we've had some activity in the chat here. I guess, Rob, do you want to come off mute and ask that? I don't quite follow your question.
Okay. Thank you. This has been a great presentation. I'm quite inspired by it. I know that our group has been looking at different kinds of workflow systems, and there's things like Pegasus that came up and so forth in this, and it's all very relevant to things we're thinking about. So the question is, when it comes to reproducibility, there's almost like three major components I can think of that like a data center doing computation needs to be concerned with, and that is versioning of software, versioning of metadata, and versioning of data. And since we're mostly focused on code here, I was just wondering if you could review it within this targets type of workflow structure, what is the proper way of basically doing an earlier version of certain computational components to simulate as something that was run 2 years ago for a published paper. If you wanted to perfectly reproduce it, naturally, warts and all, you would want to reproduce the code as it was at that point. What's the best practice?
That's a great question. So first, you will notice that this presentation, we don't really talk much about Git, GitHub, or containers. That is because that's too much to talk about in one presentation. So from the code perspective, a lot of things that we do in our day-to-day is like we'll include a Docker container to capture the software dependencies. Your question about the data itself, that's a good question. And I would say it depends. So for example, WQP specifically, you cannot archive the data. If you run the same analysis on a Monday versus a Friday, and a water science center has done something to update their data, you're going to get the updated data. And that's sort of outside of the scope of this, but a very good question.
Right. Yeah, I understand. So yeah, so just for your code, it looks like what you have in this structure is the ability to incorporate a workflow with certain nodes being of older versions, something that was running at a particular time. And so when it comes to assembling a target's make, there must be some way that you can say, okay, I'm going to build this as it would have built 2 years ago by referencing certain version dependencies of libraries, version dependencies of function constructs, et cetera.
So when we publish, we do that in 2 ways. One, we always try, like when I build a targets pipeline for a project, I'm always trying to hit citable data, upstream data sources. That's not 100% always true, but like I'm working on a national water availability assessment, and everything being delivered to us comes from a science-based item, and science-based is sort of like the USGS archive for published data sets, and science-based does the data tracking. So that's one way we get around it. 2, we include a Docker container when we publish a paper. And this is speaking specifically from my perspective here. We include a Docker container, and then we will usually do something in Git to say something about, we will freeze the pipeline in time and apply a version number.
Oh, that's great.
And then that will get cited, because a lot of these pipelines, if you build a pipeline really well, it will get used a lot.
Yeah. And
so being able to grab your own copy, apply some kind of version number, and then say, okay, well, this was used to make this paper.
Yeah.
That's one way around it. And then having the Docker container will manage the R dependencies.
Okay. Yeah.
And I will say that the best method for doing this is something that we're actively working to define in USGS, but different teams operate slightly differently.
Okay. Thank you.
Yeah, there's a little bit of chat on this as well. And I don't know if Julie, I know Jesse Ross has been experimenting with the data version control system.
That's probably the hardest piece. And I will tell you, it's CDI, we had the lead developer for the WQP in our seminar for this, and he asked the crowd, he said, hey, would you guys like to be able to freeze a WQP data set in time? And like everybody was like, yes, we want that. But so it's something on his mind, but it doesn't exist.
Yeah. Yeah, for operational systems, it's incredibly difficult sometimes to imagine, can we create a query caching, query result system that is scalable but also not going to break the bank?
Exactly.
It's a tricky question.
So this is this is Matt Jones. I raised this in the chat about the content ID work that Carl Bettiger has been doing. It's really, I think we recognize that all these different systems that we access for data from have different policies about versioning, and you really can't control the whole world. So content ID, has the perspective of like, okay, we're going to grab what we grab, and we're going to take a hash, and we're going to make sure that we track what we used, and then we can at least detect when something has changed on the source end, and then react to that, right? And content ID has a really nice caching system that works with a whole bunch of distributed data repositories, like so Data One and that Preston system, and then Software Heritage and other groups are supporting it. And so you can really you can find out, for example, like if there are 10 copies of a data set around, but they all use different local identifiers in those systems, you can still find them the exact copy that you used somewhere else out there in the data repository landscape. So I think there's a lot of promise for this, like as a ad hoc way of like recording what you actually used during a particular run of an analysis. So yeah, I think it's an interesting thread.
Well, and what I also like about it is that it's like, it ensures that you are doing the analysis that you say you do. In the write-up, it's very much show your work. And that's what I appreciate about it. And sometimes, I mean, I've been on projects here where, you always think you've provided enough documentation, but I had a legacy pipeline handed off to me. And the write-up didn't seem quite complete, but I was able to go into the pipeline and figure out what was going on, and I love that. And the other added advantage of working in pipelines, I think, is it makes it easier to onboard people onto projects. One project that I'm working on had a change in the lead author for a chapter. And because I had the whole analysis in a workflow, it was very easy to orient. I found it very easy to orient the new author to different items. And then he could come to me and say, hey, I'm looking for this product. And I could say, it's this target in the pipeline.
So I was going to ask a question, and that's a good segue into what I was going to talk about. Are you familiar with the framing of this idea of literate programming?
Yes.
Can you talk a little bit about literate programming in the context of a target pipeline or targets pipeline, or otherwise? Because I think your step of like organizing your scripts, that to me is literate program. That's applying the concepts of literate programming to what you're doing.
Yeah.
And I guess, can you talk a little bit about that?
So for context, I know what a Jupyter notebook is. I don't use them, but that's simply because I haven't really had the opportunity. You know, I would call of our last example, I think that's what I think of as literate programming, I guess. But I'm open to definitely a more expansive definition. And like, you know, one thing that we do is that my analysis was very simple. But in real world analyses, they get kind of complicated. And sometimes you have to add a bunch of extra information to a given target. Like, you know, so sometimes the pipeline doesn't always quite work how you had hoped. So you need to leave very explicit directions on what the next user should keep an eye out for. And all of the pipelines that we build come with a lot of inline commenting. They come with informative readmes, and all functions are documented. If I'm reviewing your code, you're going to have function documentation, or it's not going to be allowed in. So all of those pieces sort of come together, I suppose, to arrive at a literate programming approach, but it's not as explicit as like a Jupyter notebook, where it's like, here's a description, run this chunk. Here's a description, run this chunk.
But to me, your documentation of steps that dropped right into target comments, that's the, I guess I think there's more value to doing that than meets the eye. And structuring your work so you can describe a step as like, this is doing this, this is doing this, right?
Yeah, and this is a broad overview, but like, you know, this is why, you know, at least in the data science branch, we really treat this as a discipline. You know, I have junior data scientists that I work with. We're in the water mission area, but we regularly hire people that we think have programming expertise, but may not have the domain expertise, because the water mission area is full of those experts. So we really focus on the infrastructure around these analyses and thoughtful, like some of these analyses get really complicated and you need to think thoughtfully about the breakpoints you're using. Targets does have a maximum number of branches that you can make. So you need to think thoughtfully about how substantial a unit of work is. And then documenting as you go.
Cool. Any other questions, comments? Personal rants and raves? If you all haven't seen it, I would highly recommend going back and watching Mike Mahoney's rant and rave about basically this topic, because he goes back in time a little bit and talks about make as well. The relationship back to older technologies for tracking workflows as pipelines is very strong here. Like the concepts haven't really changed for a long time.
I think the makefile concept can always be appreciated as well. And I definitely like the fact that you get accelerators for dealing with only the parts of the workflow that have changed where possible.
The other thing I like about targets, and I think, I'm not sure how other organizations are, but we have a very large R user community in USGS. And we have lots of folks that are familiar with scripting, but like, you know, I think a lot of folks on the call would be very comfortable in a makefile or in the command line and stuff like that. And that's just not the lived experience for a lot of the folks that I work with, they're a little bit intimidated by it. So being able to have a make-like system within R and R Studio is extremely powerful for bringing people along as we try to improve coding practices.
Yeah.
Yeah, the ability to have kind of an interactive environment where you're doing super legit workflow and pipeline development is a pretty big deal.
Yeah. And I think it's interesting that there's also some languages, workflow languages, that are getting away from the idea of having a separately declared workflow and instead using annotations, code annotations, to basically build your dependency graphs, both process and data dependency graphs. And that works really well because it's a lot easier to maintain, like just like documentation. If you keep it really close to your function definitions, then your workflow is much more maintainable. And so Parcel and Ray both take that approach, where you basically can annotate any function with its dependencies, and it's really good at doing what computers do well, which is trace dependencies automatically. So it's
That's interesting. All right. Well, we're up to the end of our time. Thank you so much, Julie. That was really good. We will get the recording up on YouTube and get the wiki page updated for everybody. And we'll be in touch for next month, where we will hear from the Model Data Research Coordination Network on their work on archiving models and model results. So
Great. Thank you for the invite.
yeah, absolutely. With that, have a good rest of your week, everybody.
Thank you.
Thank you.
See ya.